Okay, so up until now, we've only been working with the perfect squares and the square roots. What we're going to go into now is something that we did a little bit in seventh grade, not a ton, but we did talk about it just a little bit. And it goes into estimating square roots. So we have perfect squares and those perfect square roots, but those are not the only kind of squares out there. They are not. We can estimate imperfect squares by using a number line. Let's take a look at that word imperfect. It's one word. I kind of put a little bit of a space there because I want to talk about this root, that prefix im. That prefix im, does anybody know what that means? That means not. So these imperfect squares are not perfect. They're not going to be from that chart that we had at the beginning. It's not going to be one of these pretty square roots. It's not. They're considered not perfect, or so they are considered not rational because they are really the actual real square root of these numbers are really going to be decimals that do not repeat or terminate. These decimals do not repeat, so it's not going to be the same number over and over and over again, and they do not terminate. Non-terminating decimals are decimals that do not end. Again, this prefix non also means not. So that means these decimals, they do not end. They're going to keep going forever and ever and ever and ever and ever and never stop, never repeat. So now that we've got a lot of that information, let's see what we're really talking about. So looking at our squares on a number line, or square roots, I should say, on a number line, we know 1 is the square root of 1. 2 is the square root of 4. 3 is the square root of 9. 4 is 16. 5 is 25. 6 is 36. So on and so forth. And you guys get what I'm saying, right? I'm going to pause this video, finish filling this out, and I'll come back to you in just a second, okay? Okay. Two to 6. There we go. So those are our perfect squares. But these imperfect square roots are in the middle between them. So I know 1 is the square root of 1, 2 is the square root of 4. What that means is between that 1 and 4, I'm also going to have the square root of 2. I'm also going to have in there the square root of 3. And then 2 is the square root of 4. After 2, which is the square root of 4, and there's going to be the square root of 5, the square root of 6, the square root of 7, the square root of 8, and then 3 is the square root of 9. So in between these perfect squares, we have all of these imperfect squares, these ugly numbers. Like we said, these imperfect squares They do not repeat. The decimals do not repeat, and the decimals do not terminate. Again, what does terminate mean? End. They keep on going forever and ever and ever and ever. I wanted to show you what that looked like on the calculator. So if I open up Desmos right over there, if I want to type the square root, I'm going to be clicking this button right here. So I want the square root. Let's do the square root of 2 right after 1. So what number times itself is going to give me 2 exactly? So the square root of 2. And then I see over here it's 1.414213562, but that's not it. The calculator gives us a rounded answer. There's a lot of decimals there, but that's not the real number. Your calculators, they just round a little bit. Let me show you what it looks like on my phone. So on this calculator, I have to flip it sideways. If I want to do the square root of 2, I push the 2 first, then I push my square root button. This one gives even more decimal places. This one tells me 1.414213562373095. But again, that's not the end of it. This number keeps going, going, going. The decimal does not repeat. That decimal does not stop. It keeps on going forever. Let's take a look at the square root of 3. Again, I want to type the square root using that number there. I press the, hang on. Let's clear this out. There we go. The square root of 3 is 1.732050808. And right there, it looks like it's going to repeat. But let's come back to this calculator. If I want to do 3, the square root of it, I see that we do have that 080. It rounded that 7, 2, and 8. Because we see after it, the number is going to keep going. It does not terminate, it does not end, and it does not repeat. On your own, I want you guys to try the square root of 7 on your calculator on your own. So if you haven't yet, pause the video, open up Desmos, and I want you guys to try the square root of 7 for me. Pause the video, and then when you come back, we'll check and see if we got the same thing. Okay. All right, so the square root of 7, we get 2.645751311. That's so great. The reason that we want to use this number line to help us approximate square roots is because with this standard, what they want you to be able to do is to determine the 2 consecutive integers between which a square root lies. So what they're really wanting to know is if I have a number line like this, I want to know between which of these numbers my square root is going to be. Between which of these integers, these numbers on my number line, where is my square root going to be? So if I know my integers, if I know their perfect squares, I can figure out where my number is going to be. So let's come down and do some examples together down here. Between which 2 integers would you find the following numbers? So I know that problem number 1, they want me to know between which 2 integers. Again, those integers are the numbers that are in yellow. Between which of those 2 numbers would we see the square root of 10? So pause, and I just want you to think about that for a second. The square root of 10, knowing all those perfect squares, which 2 numbers is the square root of 10 going to be between in that yellow? I'll give you a second. Just think about it. When you have an answer, when you have an idea, give yourself a little light bulb so I know you're ready for me to keep going. Okay, so the square root of 10, again, I want to look at my perfect squares in red down there. Let me get a different color so we can see this better. So the square root of 10, if I look at my perfect squares, is it between 1 and 4? Is it between 4 and 9? Nope. Is the square root of 10 between 9 and 16? Yes. The square root of 10 is going to be somewhere in there. So I see that between 9, the square root of 9 and the square root of 16, that means it's going to be between 3 and 4. The square root of 10 is going to be close between 3 and 4 because 3 is the square root of 9, 4 is the square root of 16, 10 is somewhere between 9 and 16, which means it's going to be somewhere between 3 and 4. This is another extra question I want you to think about to see if you can figure it out on your own. Do you think the square root of 10 is going to be closer to 3, or is it going to be closer to 4? And why? Again, take a second. Do you think the square root of 10 is going to be closer to 3 or closer to 4, and why? When you have your idea, give me a little light bulb on the top of your head. Okay, now I want you to put your idea in the chat. Put your idea in the chat. Which one do you think it's closer to, 3 or 4? And if you've got an answer or an explanation, also type that in there. Why would you say 3? Why would you say 4? Again, I'm going to pause just a second and give you some time to type that in the chat. So if I'm looking at my square roots, the square root of 9, square root of 10, that's the right next square root after it, isn't it? 9, then 10, they're just right after each other. But between the square root of 10 and the square root of 16, there's a few more perfect squares in there. I'm going to have the square root of 11, the square root of 12, the square root of 13, the square root of 14, and square root of 15. There's 5 more square roots between those two numbers, but those square roots are right after each other. So the square root of 10 is going to be closer to 3 than it is to 4. Let's try another one. So 2 is the square root of 80. Like I showed you in the last problem, use those red square roots down at the bottom to help you figure out where 80 is going to go. I'm going to pause the video, see if you can find which two integers, which two of those numbers in the yellow it's going to be between. Okay, so if I follow through, I'm looking for where the square root of 80 is going to fit between, not between 1 and 4, not between 4 and 9, 9 and 16, 16, 25, 25, 36, 36, 49, 49, 64, 64, 81. The square root of 80 is going to be between there, right? Because the square root of 80 is between the square root of 84 and the square root of 81. So in here, we're going to have the square root of 80. Again, pause, take a second, and think to yourself, is it going to be closer to 8 or closer to 9, and why? Is it going to be closer to 8 or closer to 9, and why? Once you have your idea, put it in the chat. Put your idea in the chat. Ideas in the chat. Okay, so like we saw, or like hopefully most of you guys were saying, the square root of 80 is going to be closer to 9 because the square root of 64 to the square root of 80, there's quite a few square roots between those two numbers, right? But the square root of 80 to the square root of 81, those numbers are side by side, so the square root of 80 is going to be really close to 9. Let's see what it is exactly when we put it in our calculator. So I'm going to type again the square root of 9. Oh, Andrea, what are you doing? Let's delete that. We're trying to do the square root of 80. So when we type the square root of 80, we see over here, we get 8.944279191. That's pretty close to 9. If we're rounding it to the nearest whole number, it would round to 9. But again, these imperfect squares, these imperfect square roots, they do not terminate, the decimal does not end, and they do not repeat. Again, the number that we see on our calculator for the answer, that's an approximation. Our calculator rounds. That's not the real number. Okay, so again, we saw 80 was between 8 and 9. I'm going to pause the video. I want you guys to try number 3 all on your own. Use your number line to help you figure out between which two numbers it's going to be between. All right, good luck. I'll see you in a second. Here we go. Square root of 200. Tell it to me. Put it in the chat. What did you guys say for your answers? If I follow along my perfect square line, I see that 200 is going to be between 196 and 225. So that means what two integers is it going to be between? It's going to be between 14 and 15. Which one's it going to be closer to? 14 or 15? Which one of those is going to be closer to? It's going to be closer to 14. That's right. Let's put it in the calculator again just to see what we get. Clear. So the square root of 200, we get 14.1421356. And keep on going. So we were right, it is closer to 14, but it is between 14 and 5. Nice job, guys. I highly, highly, highly recommend that when you're trying to visualize this, that you are using your number line to help you figure out what numbers it's between. You get your calculator for this. So if I type in my calculator, let's say the square root of, let's say 19. The square root of 19. My decimal they give me is 4.35889. So I can use my decimal, or I can use my calculator to figure out what that number is, but then I have to think, what two numbers is it going to be between? If it's 4 point something, what two numbers is it between? Four point something means it's going to be between 4 and 5, because that would be 16 and 25. The square root of 19 is going to be somewhere between 4 and 5, because it's 4 point some decimal. It's not quite 5 yet, but it's bigger than 4. Okay, we're going to go on and do some practice work. If you have any questions, please feel free to let us know.